In this video, I'll be covering the topic called Design of Turing Machines with the examples. So what are the basic guidelines for designing a Turing machine? The fundamental object in designing a Turing machine is that in scanning a symbol by the read-write head is to know what to do in the future. So always remember what you have scanned first and what you are going to do next. So what need to be done next. And next, second guideline is the number of states must be minimized. This can be achieved by changing the states only when there is a change in the written symbol or when there is a change in the movement of the read-write head. So these are the two things you need to remember while designing a Turing machine. So the first one is fundamental objective in scanning a symbol by the read-write is to know what to do in the future. So that means whenever you are reading a symbol, so you also have to think or also have to analyze what to be done next. So and second one is number of states must be minimized. So let's see the example. So let us consider a simple example on designing a Turing machine, that is to recognize all strings consisting of even number of ones. So this implementation is similar to the design of FSM. That means whenever you read one, so that means number of ones in the I can tell whenever you get one in the that is first one in the string, that means you need to go to odd state, and whenever you get another one you need to come back to the even state. So that means in case of even number of ones, or whenever you are counting the ones for the numbers, you will always go to a two states, either even and odd. That's why I am going to write here, make use of two states, that is Q1 and Q2. So initial state is also tells is going to hold the even count. This will hold the odd count. Even count means this number of ones in the string is is 0. Even if it is 0, then what? Still it should that means it is holding the even count. So this one need to become an empty. This one need to be an accepting state. Q1 state need to be a double circled. Okay, whenever you get one, so when you get one, it need to be replaced by blank and go to the next character. So after reaching Q2 state, if you get one, you come back to the even count state, that is Q1. So again that one need to be replaced by R. So why am I changing this every once in the tape? Suppose you have only two ones, so this will be replaced by B, this will be replaced by E, so that I will get to know that all the ones are converted into blanks, and there are no characters remaining. Okay, so that is what explained in the construction. There are two states, Q1 is the initial state and Q2 is the another state, and when M enters the state Q2 on scanning 1, it writes B. So you can see here, when a machine enters the state Q2, what exactly it is going to do? It is reading the character 1 and that is replaced by character blank. So this indicates blank. Okay, and from Q2, if a machine enters into a state Q, that means after reading 1, that also converted it to blank and takes a right move that is shown in the second step. And finally remember your Q1 is finally you need to be in the final state called Q1 to tell particular string has been accepted by the machine. Now for this I am going to construct a tuples. What are the tuples? Tuples represents K, the set of states K, K sigma, this is K, that is tuples are K sigma tau delta, that is transition table, and then start state, that is Q1 here. Then the what are the replacement characters, that is B blank, and then final state. So this is blank character is B, and then here is the final state. So this is what the tuples. Let's understand the transition table. As you all know that this was the Turing machine, 1 comma B comma R, and goes to Q2, again come back to this after reading 1. So when you reach Q1, it is finally when you reach Q1, it means that the string has been accepted. So now here the transition table delta is written like this. The states Q1 and Q2, and Q1 is also represented as start state and final state, and the alphabet characters are only one you have. Okay, you can see here the alphabet character is 1. Next, Q1 on 1 goes to where? Q2. So Q1 on 1 goes to where? Q. So 1 is replaced by B. So 1 is replaced by B, and after converting that character into B, it takes a right move. That is what specified here. Similarly here, from Q2 to Q1, Q2 to Q1, Q2 on 1 goes to Q2 on 1 goes to Q1, right? And 1 is replaced by blank, and it is taking a right move. It's taking a right move. Let us obtain the computation of sequence 1 1. So let's understand the computation now. So here computation starts from the start state Q1, and the input is 1 1. Okay, Q1 on 1 goes to where? That is, it goes to Q2 state. Now the read write head is on the state. Q1 on 1 goes to Q2. You know that Q1 on 1 goes to Q2, and then it is taking a right move. So that means for the next time the read write head will be at this place. So let me write that, and before that the state earlier Q1 on 1 goes to where? It is Q2. So Q2 I will write here, and this one was replaced by blank. This one was replaced by blank. Now what is Q2 on 1? Q2 on, now let's see this. Q2 on 1 goes to Q1 state, remember, and this one needs to be replaced by blank. This one needs to be replaced by blank, and then you are taking a right move. That means to the after this character, it's taking a right move. So where Q2 on 1 goes, that is after this there is nothing, you just have a blank, and Q2 on, since Q2 on 1 goes to Q1, this Q1 should come before the read write head pointer, So that is what specified here. So if here I have not written anything, means it is blank. Okay. So you can see here now all the characters are replaced by blank, by a replacement character, and you have reached a final state. The final state is Q1. So that means this particular input has been accepted by the machine. Next, let us obtain the computation sequence of 111. Computation sequence of 111. So Q1 on 111 does what? So Q1 on 1 as usual goes to which state? Q2. So let me write here the state 1 replaced by B and takes a right move. This is Q2. This is Q1. Okay, again same thing, 1 comma B comma R. This is the final state. So now here I want to do a Q1. I want to do a computation on 111. clearly the number of ones here is odd. So it shouldn't be accepted by this machine. That means finally you should not, even if you have read all the characters, it should not land in the accepting state. Instead of that, somewhere it should land. So now let's check. Q1 on 1. So read write head is here. Q1 on 1 goes to Q2. So 1 will be replaced by blank and it should take a right move. Right move in the sense next character it should point. So anymore read write head will be here. And as I said earlier, Q1 on 1 goes to Q2. So Q2 will be now here. Okay. Next Q2 on 1. Q2 on 1 is replaced by blank and then taking a right move. Right move, that means on this character, and the state should come before the next character it is going to read. So again Q1 on 1 goes to where? Q1 on 1 goes to Q2 and it is taking a right move. So B, this one will be replaced by B and then it will be somewhere here blank, it is taking a right move, and before that here Q2 should be. So right now all inputs are done. So no more input characters left, and if you see here the states where you have landed, that is the non-final state. So that means this particular input is not accepted by the Turing machine.